Hello and welcome back. My name is Corey, you're my rubber ducks, and this is the series where we are creating a programming language from scratch. The programming language is named Tang, and we are from a terminal window using Vim as our text editor. We are, and C++ as our programming language. We are creating, a programming language from scratch, which means 100% live coding. I say nothing up my sleeves. I haven't prepared anything ahead of time. And that means you see all my mistakes. We just did a lot of work. We got functions going, and that was a huge undertaking. And then we got our break and continue statements working for our loops. And I decided I wanted to add um, arrays to our language. And in order to do that, it's going to take a little bit of work. We need the idea of, well, something to store, right? An array stores sequential values. And then we need to be able to assign values into it. So what we need to be able to create an array, be able to access the elements of those arrays, and then need to be able to assign values into it. We're not going to get to the assign tonight. No, it's too much work. Well, that's going to have to be the next video. But for tonight, we want to add in creating an array and hopefully being able to access one. So we're just going to jump in to the code, and I usually show that if I say git log, the last commit was episode 40. Of course, this is there we go, episode 41 that we're on today. So that's the last bit of work that I did, and then I'll usually say C, and nothing has changed, but something has changed, and that is if I say git diff, the only thing has changed that I removed on our to-do the continue and break. So I'm going to just commit that and say remove continue and break from the master to-do list. I forgot to do that at the end of the previous one. All right, now we have a clean slate. And what are we going to do? We are going to start off. We can't access elements of an array until we create an array. So that means we need an AST node that will represent an array being created. So which one do we want to copy? Which AST node type do we want to copy? We've got a lot of them. I will copy integer. Why not? Copy the integer, and that will be now include AST node, and we'll just call it array. If you were creating this, you could call it list if you want it to be a list, which is, I believe, what I think Python calls it, but I like array. I'm old and set in my ways. Okay, so we're going to copy integer again, and source AST node array dot CPP. All right, so another one that we're going to need, and I think I'm going to copy the AST node unary, and we'll do this as include AST node. And what's this going to be? We're going to create an index.hpp, and that's going to be, if you have a variable name and then in a square bracket that, a 3 or something, it's going to represent an index. Yeah, I think that's good. And we'll do the same thing for source. AST node unary, and now it's going to be source AST node index.cpp. So we've got integer, no, not integer, array and index. Let's edit our makefile. Ooh, it's going to be first. Array. And index then is going to be right before node float. And I haven't looked to see if there's a better way of doing this really long list, but anyway. Okay, so we need array and index. Let's go down here. So instead of assign, s assign array. There we go. And now if I look for float, there we go. And this is going to be float for, what did I call it? Index. There we go. All right, so we've got our makefile edited, and now include AST node array source AST node array, include AST node index, and source AST node index. And of course I'm going to go ahead and get my compilation started. It's going to complain. Who cares? We'll get that. All right. So we are in array. So I need to substitute integer for array all caps. And I need to do the same thing for title case, integer array. Okay. And I need to do the same thing here. And now I need to %s unary, and this should be index. And do the same thing for title case. And now all right, so let's clean up now. Let's start deciding what these are going to look like. This should all compile. It did. That's always a good thing. We'll break it now. So an array. So this AST node that represents an array literal. Arrays are... Nope, don't need that. So we have our constructor. Now, when we create an array, instead of number, we're going to have contents. Sure. The contents of the array. Do I want to call it contents though? Values, you know, expressions, contents. We're sticking with contents. I thought about it too long. And what should this be? This should be a vector of shared pointers to a Tang AST node, and we'll just call this contents and a location. The contents of the array, and what is this? This is a I should have just copied and pasted it, of a shared pointer of an AST node, contents. And I'm going to need to do pound include vector. Anything else? Oh, and the shared pointer, but I think AST node will provide that. See if it gives me yeah, no declaration matches, so I think we're okay. And I'm going to copy that, so that here we can say this. I can clean it up as per normal. That is, I don't need, oh, I didn't do vector. There we go. So I've got contents, location, contents, okay. And for this one, how do we dump this? We're going to have to say string s is equal to, that's fine. And now for auto ampersand item of this contents, s plus equals item dump indent plus, give it 2 more. Don't want to do it that way. Let's do int I is equal to 0, and then do no. We could. Well, I'll tell you what I'm thinking. This may be ugly though. ToString I plus plus. Yes, I'm intentionally doing it as a post increment. There. All right, so we dump the array. toString That's fine. It just says its size and whatever. Okay, for the compile, this is going to be interesting. We don't know what it should look like yet. But we do know that we're going to have to do basically the same thing that we did just a moment ago. Auto ampersand s, no, ampersand item, this, contents. Actually, I do know what I'm going to do here. So for each one, we are going to program.add bytecode. No, not program.add bytecode. We're going to do item arrow compile program. So each item is going to be, I mean, this is the idea of we're declaring an array literal. So it's going to have an expression, and we're going to put expression, 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 and then we're just going to say, and 5 expressions make up the stack, or make up the array, sorry. So we put this, I mean, that's what I just did, step through each item and compile it, because each one is an expression. And then we add a bytecode for array. And then we need to give it a uinteger. Probably don't have to do a uinteger, but this arrow contents arrow, not arrow, size. Yeah, that should work. That should compile. Except array isn't defined. Opcode is not defined yet. Let's define it so that this should compile. So edit our include and opcode. Where are we going to put it? We're going to put it, we've got integer, float, boolean, string. We're going to do array. And this is going to be get the len, pop len items, putting them into an array. So I can do with the last array item popped first. I think that's the easiest way to describe it. So it's compiling. Stuff may have broken. We'll find out. Okay, nothing broke. Woo, that's always a relief. Okay, so now we already know we're going to need an index type of opcode. And so to do that, it's kind of like an add, subtract. I'm going to put it after the not equal index. And we will just say, so we're going to pop index, pop collection, push collection index. I think that's the easiest way to describe it. And now let's go back to our new one. So we've got node array. We just did that. Let's do the index now. So this is an AST node that represents an index into a collection. Sure. We don't need this enumerator. Evidently, I don't know how to type numbers. Okay, so what should the index have? We don't need op. Let's call this index, and it will be oh, I shouldn't have gotten rid of the other one. Oh well, that's fine. So this is going to be the index expression. Sure. And then the first one is going to be collection. The collection into which we will index. So an array is a collection. Ultimately, a string will be a collection, right? That there may be other types of collections. Just thinking out loud. No, I think this is fine. So we've got collection index, and so we don't need operator. Why is this working? That should have to say shared, standard shared. That means I'm probably have a using namespace standard somewhere that I shouldn't. Remind me to look for that. Either way, collection, index, and location. That's fine. We know we're going to need compile. Ooh, we didn't use this in the previous one. And we do need to have a compile pre-process. We'll get there. It's going to complain about it not being defined, but that's fine. Let's see. We don't need the operator. We do need the collection into which we will index, and that is going to be called collection. And then this is going to be the index expression index. So we've got collection and index. Simple enough. And oh yeah, that's all on the next one. Now, index right here Need to get it in line. Collection. Index. That's fine. Collection. Index. Index. Okay. So for this, now this is fine. We can say our indent plus an index. Plus collection dump. Oh, well, we should really kind of say what it is. That's fine. Index, and we'll now say collection. Index, and these need to be indented 2 more. So our dump is going to show an index, the collection, then dump the collection, and then the index, and then whatever the index expression is. Okay. What is the compile going to look like? Well, we actually just did this. We're going to, or we just described it. So this collection. Oh, wait. Collection. There we go. And then this needs to be index. Okay. I'm going to go ahead and yank this and go back to this because we there we go. And this is for an array. We're just passing along to each item of the array. That's fine. Okay, now we'll go back. Okay, for the compile. And this is for the compiling of the node index. Collection compile. Index compile. And now a bytecode, and what did I call it? Just index. Is that right? The collection, push that on. Index, push that on. And then say, give me the index of it. Should work. All right. And in fact, my phone is beeping at me. I need to put it on silent. Okay, sorry. Thought that would be faster. And did I even get it on silent? I forgot. That's what happens when you get old. All right. So where are we? It's giving me, it doesn't like ST. Why? Because I didn't change the name. This should be array. There we go. Say, oh, we don't like something you did, Corey. It was probably in those pluses that I was putting everywhere. Could be wrong. Nodeindex.cpp. Line 20. Oh, of course. That's what happens when you leave, spurious semicolons around. Why not? They're free. Just leave them everywhere, scattered. All right. So everything's compiling. Doesn't mean it's doing anything, but it's compiling. The reason is because, we haven't told it how to do anything. Let's fix that. First, we'll write a test. And we'll do this. So these are functions. Let's go up. Print, control flow, code block, expressions. It's really an expression, but it's also the index. We'll do array and index. Array index. How about that? So the easiest way is to probably, I'll just test array index. Sure. And we're going to do an auto p1 is equal to Tang base. The funny thing is you realize I am doing and you may be looking at the time in milliseconds that this is taking to run. And I would point out a couple things. Number one, I keep on instantiating a new Tang base for each one of these, and normally you wouldn't do that at all. I'm just doing it for test purposes. Every time you run it, you've got a clean engine, a new instance of the object. But also, I've got all the debugging on, so I'm not too worried about the time yet. Compile script of some sort, and then expect equal, and then something. And we can probably do p1.exec execute.out, and then something. Yeah. All right, what do we want this something to look like? There. And now we have our raw string, and let's just say A is equal to 1, 2, 3, print A sub 1. And that should print out A2. Now I'm going to compile this, and I'm expecting either to get a segmentation fault because it doesn't know what to do, or it just fails. Okay, that's fine. It fails. Haven't told it how to compile that, and we haven't told it what to do when it runs into it. So let's first edit the source for program dump bytecode, and then for source program execute. We know we need both of those. That's number 7 and 8. And now we need opcode. Go back to, that's 5. So where did I put these? I put array after string. Okay. So B7, if I look for string, there we go. And we will replace this with array. And there should be one value, array, and then just the value that comes after it. That's fine. That's easy enough. And also, this is going to take a little bit more work. But, you know what, I'll go ahead and grab these 5 lines and look for string. There we go, string. And after string, put in our opcode array. And now this shouldn't be dump. It should be execute program check. And now we'll do the auto size is equal to this bytecode. That is fine. And now we will say stack, S-T-A-C-K, stack check size. We want to make sure that there's that many things available on the stack. And now we will, we haven't done the computed expression yet that represents an array. Trying to think of the easiest way to do this is what I'm thinking of. I am going to have a vector of garbage collected called contents, and it is going to be of size. Okay, and now I'm going to say for that should be u integer t I is equal to 0, I is less than you know what, forget that. We can just say nope, I can't undo that. Never. I'm arguing with myself. I know I am. Okay, that's fine. We'll go back to this. U integer t, I is equal to 0. I is less than size plus I. That's fine. And now, inside of that, what are we going to do? We're going to say contents of size minus I is equal to stack.back and then stack.popback. Okay, and then last thing, stack.push. And what are we going to push? We need to do a garbage collected make computed expression array. Have not created this yet. Should have thought ahead, but I have not done it yet. And we're going to pass in contents. Now this will not compile yet, I know this will not compile yet, but I'm leaving it there. Now the other thing is we can go to the very top and just say, hey, we need to pound include computed expression array. Doesn't exist yet, but we're going to pretend that it will at some point in the very near future. All right, what else? I think it's number, not 7, 5. So we have array there and index. Where was that? It's after not equal. So this is in the dump. Look for not equal. And now we want index, right? And it pops off the information that it's going to index, so we don't have to do anything there. So not equal is followed by index. Okay. So look for not equal. That's fine. Case opcode index stack check 2 because we expect there to be 2 things there. We'll say auto index is equal to stack dot back, stack dot pop back, and then auto container is equal to stack dot back, and then stack dot pop back. And now we're going to do stack dot push back. And what is this going to be? It is going to be the container arrow index. So we're going to create a dunder index on the on our computed expression, and we need to pass it in something. So let's pass in not container index. Increment the program counter, break. There we go. That should work. Believe it or not. Okay, we still don't know what a computed expression is. Let's write that. Unfortunately, now that means I need to... I'll do it on the right-hand side. I don't have enough terminal windows. And I know that I can go into the terminal from Vim. I just never do it, so I don't know how to do it off the top of my head. So, okay. We're going to copy the include for computed expression. And what do we want to do? This is a computed expression array. And which one do we want to copy? What's it closest to? That's it, integer. And include computed. Yeah. Sorry, I second guessed myself for just a moment. We're going to copy source computed expression integer to include computed expression array.cpp. We're going to go into Vim, our make file, and add a computed expression array, and that's way down here. There we go. Array. And now, there we go. We will substitute the word Boolean for array. And those two lines, we're good there. We're going to tell it to compile. It's going to complain. What did I do? Huh. I copied source.cpp into include. So I need to move include computed expression array.cpp to source. Okay. That was just me going on autopilot and getting it wrong. All right, so does this our program execute? Sorry, thinking out loud. Let's go ahead and edit our... I said we're going to need this index thing. So let's add that. That's going to be, we need to edit the include for a computed expression. And we can do that here. We've got add, subtract, multiply, less than, equal. We were putting it before the casts, right? Sure. Let's see. Perform an index operation. And that is, we're going to need a param is going to be the index. And that is the index expression. Provided by the script. Sure, why not? And at return is the result of the operation. We use that a lot, I know. Virtual garbage collected dunder index. We're going to give it a const garbage collected ampersand index. It's going to be const. All should be right with the world. It's going to, well, if it gets as far, it's going to complain that it's not defined, but I don't think it's going to. So now let's edit our source for computed expression.cpp. That's fine. And let's yank this one. Instead of integer, it's going to be index, and don't know how to index this expression. All right. Oh yeah, because we need to pass in something. We need to pass in a const, excuse me, maybe unused const garbage collected ampersand index. Say, Corey, when are you going to learn how to spell? I don't know. G-A-R B-A-G-E. There. Forget trying to Okay, we're back to errors. Good. Let's see where this is. Oh, that should be pushed back. So that's program.execute. $182. Oh, it's in the other one. Y'all let me do that? How dare you? As my rubber ducks, you are supposed to catch those silly mistakes. Computed expression array was not declared, and that's because I probably didn't include it. Oh, wait. Pound included that. Computed expression array. Did I mistype something, or have I not done it yet? Oh, haven't done it yet. Oh yeah. Source computed expression array. Oh boy. Why did I copy integer? There's so much in here. That's fine. Okay. %s, the all caps int integer is being replaced with an all caps array. And the title case integer is being a title case array. And now let's pare this down, shall we? So this represents an array that is the result of a computation. I don't know. Sure. Could be a declaration, but that's fine. So what do we pass in? This needs to be a standard vector of Tang garbage collected. And that's going to be called contents. Pound include vector. Okay. So that's the first thing. The constructor is going to take, it requires a vector of garbage collected stuff. That's fine. We'll worry about the dump, what it should look like. We will worry about the make copy is equal. We're not going to do any is equal, I don't think. In fact, I think we can get rid of all of those and we will just do index and const garbage collected ampersand index. Okay. We don't need the friend. And this is going to be the array contents, and it is going to be a standard vector of Tang garbage collected. PNTS contents. Okay. We're going to do kind of the same thing here, right? We've got to do our changing everything to integer. I'll leave string just in case I need it. So for the dump, we're going to have to say, oh wait, let's do the how we're creating a copy of it. This needs to be a vector of garbage collected called contents and contents. Okay, so this is going to be, how are we dumping this? We're going to do a string. S is equal to that for auto ampersand item in this contents. S plus equals that's just gonna, so we have commas after each thing, and then S plus equals item dump. Oh, and this first is equal to false. That's fine. All right. For the make copy computed expression array of this contents. Don't think this is quite what I'm wanting, but we'll should it be a deep copy? Probably. So is equal, we're not doing any of these, so I'm about to be deleting a lot of stuff here. I'm not doing any casting. All right, so now we've just got the, instead of equal, it needs to be index, and if index is, I only know what to do with an integer, computed expression integer. Index convert, computed expression index. Return this. Oh, wait. Nope, gotta do a bounds check. So we'll just say auto I is equal to index conv arrow no. I think it's val. And we want to do a test. We want to make sure that I is less than this arrow contents dot size. I is greater than equal to 0, and that if it is, then this arrow contents sub I, else make an error, and we'll give it an error to say index out of range. That should be fine. And then anything else, say invalid index value. Okay. It's probably doing some other things I don't like. Do we have... Probably made some typos. That happens. 27. Oh. Not supposed to let me make mistakes like that, right? This is return S. All right, now invalid use of incomplete type computed expression integer. Okay. Oh, that's what I get for typing while tired. Index conversion is a static cast to an integer. integer. And it's not the right-hand side. It is index. Oh, can I not get at that value? So in WSL view of our docs HTML index, there we go. Look at the class for computed expression integer. Did I ever I've never written a way to access the integer value. Just dump it to a string. That's probably a bad thing. But I'm going to slap a band-aid on it right now. And I'm not going to solve it properly. I'm not saying it's a good thing. I'm just saying that's what I'm doing. So do I have computed expression integer? No. I'm going to edit the source, not source, the include for computed expression integer. And this is not the best way of solving it. Expression array.cpp. And it doesn't like the sign comparison. That's fine. Now, where do we have problems? Well, Corey, you forgot your closing parentheses in program execute. Well, whose fault is that? On 182. Oh, it's this line that I'm on. It's not all of the problems, but oh my, oh my. There should be a push back on 182 instead of stack push. I thought I fixed that, didn't I? Did I undo it somehow? Perhaps. Index, I need a colon on line 320. You'd think I would be more careful. Okay, now it looks like we've got some fun stuff. So it's not liking something that we're doing. 177. Wait, what? Wait, am I doing something stupid here? It's entirely possible. a vector of garbage collected, and it's thinking I'm trying to... I thought that would create it with that size. Just double check. No matching function for call to construct at with the garbage collected. Just doesn't know what I'm trying to do. So C++ vector resize. Just curious if it's going to... for call to line 115. Am I... No, that's 178. Size is bytecode of PC+1, and that is that's an integer, uinteger underscore t. What I'm wondering is if I cast it to a size t, or is this not where the problem is? Oh. So the problem is, by asking it to make something, I think I realize what the problem is. By asking it to make a vector of these, watch. The problem is yeah, by asking it to make a vector of a certain size, it must be initialized to some value. So that means it would take the default empty one, but I don't think we have a way of making a garbage collected with nothing. A garbage collected value that is just, yeah, empty. Maybe we should. Maybe we should. Okay, that's fine. What we'll do for right now is contents dot push back Do I want to do it this way? So I could do it as stack of FP. No, 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 because I don't know. Stack.size minus size plus I. That's really the only way to get that. And then do it again, but just calling the pop back. So don't do the pop back until then. So copy them in order and then remove them. And then I can do content.reserve size. So just saying, hey, prepare for this many. Hey, it's compiling again. That's always nice. Say, why isn't it working? Because we still haven't done Flex and Bison. We still haven't told it anything about that. Let's do it, shall we? So what we've been doing at the moment is we've been kind of creating the parts before even trying to put them together. And you can approach it from either side, right? The only problem is I already have a mental construct of what this should look like, and you don't. And so it's, well, unless you've done this before, can read my mind, or maybe you can see where we're going. But it's that we either have to start the Bison and Flex side and say, okay, build this, but they don't exist. I mean, these are the patterns and everything, but they don't exist yet, so we build that way, or we start at the other end. And I've gone both ways in this episode series. And I started at saying, okay, we're going to need our AST nodes, we're going to need our computed expressions. I'm putting it together, even though we haven't written any code that actually represents it. So well, that's what we're doing right now. So Flex and Bison. Now I'm going to start off in Bison. Usually we've got an L brace and R brace. Let's do a percent token L bracket? Sure. And percent token R bracket. Okay. Now, I guarantee you I'm going to need to do order of operations for this. So, C++ order of operations. And they are down there with the, well, they call it subscript, but they're with the function call. And that is, of course, left to right. So, anything else? No. Okay. We're going to need to pound include our AST node array and index. index. Okay, array and index, that's fine. And now let's go into flex and tell it how to recognize this. Right, here they are. L brace and R brace. And now it's going to be L BRA bracket and R bracket. Flex didn't give me any errors. Bison, we don't know yet. There's two things I want to change. Not really two things, one thing. That is this right here. So in our function arguments, I want this, instead of function arguments, I want this to be called expression list, because it recognizes an expression, comma, expression. Well, that would be in function arguments, but it would also be in our array definition. So if I just say that, and it'll tell me, oh, where is it broken? Okay, 131. Excuse me. 258. And this should be function argument should be if I save this, everything should be fine. Oh, yeah, 486. Everything should still pass, except for the one that we've written a test for arrays that doesn't work. Good. So, this is an expression, right? So first, let's do yeah, this will work. Sorry, had to back up for just a moment and make sure that it made sense in my head. And what we're going to do is, yeah, we'll just yank that one. And instead, so we're going to, this is an AST node array, and we're going to pass it, no, this is an index. An index, because we've got an expression, that's the first one, and then the third one is the expression list. Okay, and that's the first one, and then we also need the literal. Do I have that? Nope, I'll just go back down to where I was. Oh, I'm wrong. This should have been expression. Yeah, an expression with a single expression in it is an index, but the single quote or the left bracket expression list right bracket is going to be an AST node array with only that. Let's see what I broke. Expression has no declared type. What? $1. Oh, it should be $2. Do that sometimes. No. There is no way that it just worked. But the test passed. Test, 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 test. This test passed. If I run it again with 2, 2, and I should get a 3. I'm going to leave it as a 2 just so it will fail. And it did. Replace that with a 3, which is what it should be. Pass. Okay. Now, let's try another one. Sorry, it's like I hit the wrong button somewhere and R3, 3. I'm going to do something that may look a little weird. This, if I do get result, it should just be a 2 because I'm not compiling as a statement, I'm just as an expression. That's passing. Good. Now that means I can test what if I do a 4? It should give me an error. That's what I'm expecting. It does index out of range, which is what I wanted it to do. And so error index out of range. Passed. A -3. thinking if I want this to behave like Python, this should not give an error, but for right now it does. It does for right now. We may change that later, but for right now. All right, so what else do we want? I want a mixed test. I want an A and true. And I want this to be A is equal to print A sub 0. Just print them all. Shouldn't be wait, what? I don't think if I try to print true, I don't think it has a way to printing to true. But if I do it as, instead of true, if I do a (1.5), sure. It should be 1A 1.500, a bunch of zeros. Yeah. 1A 1.5000000. Yeah, that's 6 digits. So I can access it multiple times. I don't have a way of changing the values in the array, but I have an array. And I don't have a way of getting the array size or anything like that because we don't have bound functions. That's going to have to come later. But I have an array. And I can live with that for right now. So, let's play a little bit of cleanup, shall we? What all is there? 6 untracked files. Let's first do the not get status, get diff, and see what we've changed. Make sure everything makes sense. Of course, we've added the new stuff to the make file. This is to Bison. Makes sense. And in the meantime, over here, make clean, make test, and Bison is not reporting any shift reduce conflicts, and Flex didn't give us any errors, so I mean I saw that earlier, but don't think that's changed. Okay, let's see, continue on the left hand side. All the tests passed on the left-hand side. That's always good. Okay, now one other thing I want to do, and that is look for the word array. There we go. I want to cout P6 dump bytecode. The reason is I want to see the bytecode that I created for this stuff, and here we are. So we have a null val that will be the variable a, and then we've got the string a that got pushed on. That means, well, I mean, we could have seen that happen already, but it's the fact that it, the preprocess, compile preprocess, did in fact go through. That's fine. Integer 1, that's going to be the, yeah, integer 1 is the value 1. Peak 1 is a, float 1.5, array 3. Puts all three of those in there. Poke that into 0. That's a. And then pop. Then peek it back. Peek that, peek 0. Do the index, print it, pop the result of print. Peek 0, integer 1, index, print, pop. Peek 0, integer 2, index, print. Yes. That's good. I'm very happy with that. Okay. Can delete that line. I'll recompile. Include source. Yeah, that's fine. Add arrays and indexing to the language. As usual, let's rm-rf docs. Oh, and by the way, we can see here we added 365 lines, only 7 deletions. Make docs-pdf. Remakes everything. What episode are we on? Episode 41. All right, so uploading. Tag, get push, origin. It's there. As usual, we run that and we're up to 5,200 lines. Okay, but we have arrays. And so what do we not have? We don't have the ability to add to them, to append. You know, we don't have the ability, we haven't checked for equality of the arrays. We should probably do that. But I don't think we can do the append or any, yeah, until we get bound functions, and that's going to be just a little while. I'll probably tackle strings or the Unicode strings before then. Not sure. I'll think about it. But first, we don't have assignment. We can't change the value in an array. We want to be able to do that. So we'll probably be looking at that next. And yeah, in the end, though, I am glad to say that this is less than 2 hours long. And that is, as of late, that's a big accomplishment. But as always, I hope that this was marginally useful in some way to someone out there. And thanks for joining in. Thank you, and have a great day.